We're going to learn about prime factorization. So let's talk about those two numbers. Factorization means to break a number into what's called factors. Okay, now factors are numbers that multiply. Let me get this focused right. We're going to break a number into factors. Factors are numbers that multiply. So for example, the factors of 15 are 5 and 3. Okay, 15 also has some other factors. 1 and 15 are factors of 15. Okay, now we're going to break down numbers. Okay, we're going to break a number into its factors until we get to prime numbers. Now, prime numbers are only divisible by 1 and themselves. What does that mean? So like, for example, the number 5 is prime because it can't be divided by 2 or 3, only by 1 and by itself. Okay, so I'm going to just list the numbers to 20 and we're going to decide if they're prime or not prime. Okay, now 1. 1 is not considered prime or not prime. Just don't worry about it. We don't factor 1 because it can't really be factored, right? It can only just be divided by 1. That's it. Okay, now 2. 2 is prime, right? 2 can only be divided by 1 in itself. 3. 3 is also prime. 4 is not prime because 4 can be divided by 1 and 4, right? But also by 2. 4 divided by 2 is 2, so 4 is not prime. 5 is prime. 6 is not prime because it can be divided by 2 and 3. 7 is prime. 8 is not prime. And you might notice these are all even numbers over here, yeah, because they can be divided by 2. The thing is 9 is not prime, right? You might notice, oh, the odd numbers are here. But 9 is not prime because 9 can be divided by 3. And 10 is not prime because it can be divided by 5 and 2. 11 is prime. 12 is not. 13 is prime. 14 is not prime because it's even, right? Even numbers can be divided by 2. 15 is also not prime because it can be divided by 5 and 3 like we put up here. 16 is not prime. 17 is prime. I didn't leave myself quite enough space here. Okay. 18 is not prime. 19 is prime. And 20 is not prime. Okay, so you can see we have quite a few prime numbers that we're going to watch out for when we get into prime factoring. Okay, so here is how we prime factor. And you have for sure seen this before, but I'm going to show you as if you haven't. Here's how you do it. You make the tree's root. So here's your tree, right? And I'm going to dig some roots into the ground here. I'm going to find two numbers that multiply to the number above. Okay. Now, as I'm going, I'm going to stop and circle when I get to a prime number. Let me show you what that looks like. I'm going to think of two numbers that multiply to 75. Now, off the top of your head, you might not think like, oh, this times this is 75. That's easy. You might not know. Okay, so a couple things you can think about. First of all, for a number like 75, I think to myself, well, if I have 75 cents, I have 3/4. So like I right away think of 3 and 25. Okay, so you might have like just some life experience that helps you think of numbers. Okay, another thing you can look at is you can use divisibility rules. So for example, a number, if it ends in 0, 2, 4, 6, or 8, it's divisible by 2 for sure, always. A number is divisible by 3. This is kind of an interesting one. If the digits are divisible by 3. So for example, the number 57, you might not just be able to easily think, oh, 57 is this divided by this. But if you do 5 plus 7, you get 12. And then, right, because the digits are 5 and 7. And then you add the digits again, 1 plus 2, that's 3. Okay? If the digits add to something divisible by 3, right, like 12 divided by 4 is 3, this number I now know is divisible by 3. So I can use a calculator if I need to, right? But 57 divided by 3, it turns out is actually 19. So if I were factoring 57, I would say, oh, well, I'm going to think and I'm going to do some of these divisibility rules. Now I know it's divisible by 3, and then I can put 17 on the other side. And then a number is always divisible by 5 if the number ends in 0 or 5, right? Now if it ends in 0, it's also divisible by 10. But if it ends in 0 or 5, we know that it's divisible by 5. So you can kind of use these rules to help you get started if you're stuck on a number. But here, I'm working on 75, and I've ended on a 3 here, and this is a prime number. So I'm going to stop it, I'm going to circle it, and I'm not going to factor any farther because that's prime. I can't factor, right? I could do 1 and 3 and then factor 1 and 3 again, but I'm not going to do that. That's silly. Is 25 prime? No, 25 can be factored. What two numbers multiply to make 25? 5 times 5 is 25. Okay, now 5 is prime. So I'm going to stop and circle. And here's how I write this. I write that 75, the prime factors of 75 are 3 times 5 times 5, like this. Okay, so in fact, there's 2 ways to write it, but I'm going to put this one in line. 3 times 5 times 5. Okay, so this is called the prime factorization of 75. I have broken it down into prime numbers. Now I want you to notice that if I multiply these together, I get 75, right? 3 times 5 is 15, times 5 is 75. I could multiply them in another order. 5 times 5 is 25, times 3 is 75. And I want to point out that had I factored and said 75 is 5 times 15 first, I would have ended with the same answer. Okay, you can also write this like this, 3 times 5 squared, right? That means 5 squared is the same as 5 times 5. Let's do 48. Okay, now if you think to yourself right away, and you can think of 2 numbers that multiply to 48, right? Cool, you might think 8 and 6, you might think 12 and 4, you might think 24 and 2, there are lots of possibilities for 48. If you're stuck, you look down here and you say, oh, it's even. I can divide it by 2. It turns out it's also divisible by 3. Okay, so you can even, put a 2 here, say, okay, that's prime. And then put in your calculator 48 divided by 2 and realize, oh, that's 24. And then you look at 24, you're like, I'm blanking. I can't think of any numbers that multiply to 24. Okay, you think, well, that's even 2. I'm going to take a 2 out of it. 24 divided by 2 is 12. And maybe you're blanking and you still can't think of a number that that's fine. 12 is even. Take a 2 out. 6, ooh, that's also even. Take a 2 out, right? This is fine. This totally works. So 48 is 2 times 2 times 2 times 2 times 3. And just, keep count if you end up in this situation. But this totally works. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. So there's your answer. You could also write this like this. 2 to the 4th, 1, 2, 3, 4, times 3. Okay. Now, what if you go to factor 31? You're like, what are numbers that multiply to 31? Let's see. Is it even? No. Can it be divided by 3? No. Can it be divided by 5? No. You might think, oh, can it be divided by 7? How about 11? Nope. This one's actually prime. So you're done. 31 is prime. You could that is the prime factorization of 31. You're all done. Okay? So right now, you've seen me do some. You're going to go ahead and try these so that you can practice the process a little bit on your own. If you get stuck, use these divisibility rules. Okay? Use your calculator, ask a friend, ask for help, but try these out.